Today I'm going to explain my project in operating system subject. I took the topic real-time operating system. Um First, what is RTOS? A real-time operating system is a program that schedules execution in timely manner. They manage and monitor system resources and provide consistency for a developing application programs. Application of an RTOS range from simple application for digital stopwatches to the navigating systems of aircraft, which is more complicated. Unlike GPOS, RTOS can applied in not only complex but also simple environments, which means scalability is a key factor of a good RTOS. And RTOS copes with the software by providing minimal logic, scheduling, and resource management algorithm in their kernel. Especially, every RTOS has their kernel combined with variety of modules such as file systems, networking protocols, stacks, required functions for a particular environment, which is shown in the figure 1.2. It's here, you can see that figure 1.1. And the next one is a brief history about RTOS. At the beginning of the development of computing systems, people created low level programming codes to directly interact with the hardware. However, this is made the application non-profitable. Even minor changes caused rewriting of a considerable part of the application. With the evolution of the software, computer systems are now able to use the benefits of abstraction of underlying hardware by the applied codes. As the operating system evolve, applications become modular and interconnected, and the operating system supports the modules under them. Various variants of operating systems have been invented for many years. General purpose operating systems like Unix, Windows were developed to support various software on general purpose environments. For systems demanding a smaller and compact operating system, real time operating systems such as VxWorks were developed. From 1960s and 70s, Unix enabled multi-user access and various tasks to shade the use and expensive computers. And in 1980s, Microsoft Windows started to support the personal computing environment. They confused on usage in home and business with graphical user interface. Um, and recently, the embedded computing era has started with the development of commercial RTOS like VS Works. These days, GPOs focus on supporting personal computers, workstations, and mainframes. Sometimes, soft real-time features were needed by embedded devices. In contrast to GPOs, RTOS were suited to limited memory and high-performance environments. They are more reliable but compact and scalable. When it goes to next step, it is design goals of RTOS. RTOS are better for real-time embedded environment than GPOS because RTOS supports some important functions, for example multitasking, resource management for software and hardware, support for core OS services to applications, abstraction of hardware from software level. RTOS support key functions for real-time applications, better reliability in embedded applications, scalability to meet application needs, faster through output, low memory requirements, scheduling policies for real-time embedded environments. Diskless embedded systems using executable to boot and run from ROM or RAM, better portability to various hardware. And to implement an RTOS system to satisfy these, an RTOS kernel includes RTOS objects, schedule, task management, input output management, synchronous communication, memory management, and which is shown in the figure. It needs all. And the next step is memory management of RTOS. Understanding memory management is a key aspect because embedded system developers normally implement their own memory management facilities. In many embedded applications, dynamic memory allocation routines are often being used. Even though it can create an undesirable memory fragmentation, this is widely being used. Also, such implementation can impact an application's performance. Many embedded devices, such as PDAs, cell phones, or IoT devices, have unlimited tasks for parallel runs any given time. Moreover, the devices have a small amount of onboard memory. On the other hand, larger devices such as network routers, web services have memory, but they typically operate in a more dynamic environment, so they demand more memory. Nonetheless, the common requirements for memory managed system and systems are minimal fragmentation, deterministic allocation time. Uh, an RTOS system utilize memory compaction using memory location map. The memory compaction is um, allowed by a task owing those memory blocks. And it refers to the blocks using virtual addresses of its memory. Memory compaction is not permitted when tasks are holding physical addresses. Memory alignment also refers to architecture specific constraints on the address of the data in the memory. To be specific, some architectures require multiple bytes data, like a long integers, to allocate them addresses of a power of 2. If the memory addresses are not aligned, there will be a bus errors and memory error exceptions. Therefore, memory compaction doesn't generally perform in real-time embedded system. To solve this problem, well-designed memory allocation functions in RTOS allows blocking allocation. Moreover, RTOS do take advantage of protecting memory in spite of possible fragmentation. And the next point is process management of RTOS. A task is a schedulable. The task is able to compute for execution time on a system based on predefined scheduling algorithm. A task is defined by its own distinct set of parameters and supporting data structures specifically. Each task has an associated name, unique ID, priority, and if a part of primitive scheduling plan, a task control blocks PCB. A stack and a task routine is shown in this figure, and together these components make up what is known as the task object. Here we can see everything, like, yeah. All embedded systems include some from of an input-output operations. These operations are performed over different types of input-output devices. A vehicle dashboard display a touch screen on a PDA, the hard disk of a file server, and a network interface card are examples of input-output devices found in an embedded system. Often, an embedded system is designed specifically to handle a special requirements associated with the device. Mm, device man. So often, an embedded system is designed specifically to handle the special requirements associated with the device. A cell phone, pager, and the handled MP3 players are few examples of embedded systems built explicitly to tool without input-output devices. And the next step is uh, file management system. And the next step is security management. The real-time operating system is a computing environment used in the systems that require a response within very specific time constraints. The correctness of the system depends on just on the correct logical result, but also on the delivery time of the result. For most applications, real-time performance is the main creation in evaluation of RTOS. RTOS employs several methods to ensure that it meets the real system requirements. This make RTOS mostly a single purpose system. And currently, security issues in RTOS is electric power that goes to your house, water pumps that pumps water into your house, what that goes out of your home, traffic lights, public transportation, air conditioning in the building you work in, the cell phone you use, natural gas that goes to your house. Uh, there are two folds to security relating to RTOS. Security within the RTOS revolves around the ability to keep the job separate. So one task does not interrupt another. This problem becomes more complex as RTOS is needed for more complex applications while still keeping its deadline requirement. RTOS is in a network. It is used to wide variety in industry include electrical power grids, traffic signals, water management, as I said before. And the next step is the popular most popular RTOS. It's Windows CE, Linux OS, VxWorks, and QNX, and MUX, Nucleus, and Safe RTOS, Free RTOS, and there are some more like Zip Hair. Like these are all popular RTOX as shown in the box. And the next step is benefits of using an RTOS. Allows you allows you to split the priorities the application code. The RTOS always runs the highest priority task that is ready. Adding low priority tasks don't affect the responsiveness of high priority tasks. And the next one is tasks waits for event. Avoids polling. RTOS make it easy to add middleware components. TCP, IP stack, USB stacks, file system, graphical user interface. Creates a framework for developing applications. Facilities teams of multiple developers. It's possible to meet all the deadlines of the applications. Rate monotonic analysis would be used to determine the schedulability. And like this, drawbacks of the using an RTOS. The RTOS itself is a code and thus requires more flash, typically between 66 to 20 kilobytes. An RTOS requires extra RAM. Each task requires its own stack. The size of the task depends on the application. You have to assign the task priorities. The services provided by the RTOS consume CPU time. So these are the drawbacks of the RTOS. And the next step is future direction of RTOS. As we discussed in the previous sections, RTOS is being widely used in various embedded systems. Although RTOS provides powerful features like multitasking, reliability, and better performance, these are still challenging issues like deadlock issues. Also, scalability is one of the important key factor of the good RTOS. New generation of RTOS system has have to implement power proper systems by satisfying these requirements and solve such problems. These are the total my project. Thank you for the listening. Thank you.